where's the agenda? All right, Marin, you want to take it away?
Yes, I again was investigating for my own purposes, so I just added these items. Yeah, ongoing work with cloud job logs, one MR remaining before rollout, and then pages was got an update with the zip implementation, and that was merged and deployed to staging in production. And I see Camille is here. So Camille, do you want to share, because this is your team's win?
It's not really my team. I'm only helping there. So like you can click links and like play with it. It's running. There is like still small delay that it's really not noticeable. Something that we are working on improving, but it works. And like as one of the benefits, because of the data compression, we store in this particular example 3 times less amount of the data for serving docs GitLab page. So,
hey Camille, congratulations on that. That's super fast. I find this zip thing not very intuitive, but I think it's a Dutch person thing, because Jacob also had a lot of questions about it. Jacob Vosma. Can I kind of relay what I think the summary is of how this all works and why this is a good idea, so you can kind of fact check me? In order for GitLab pages to work in a kind of a Kubernetes cloud native way, we need to move to object storage. And what we could do is, when we generate a pages site, put every individual file in object storage. It can be a ton of files, like 25,000 of them or something like that. And we would need to kind of keep a database where all the different files are. Plus web servers kind of expect a file server most of the time, so we'd have to figure out something for that. What we've decided to do instead is, when we generate a static website, we compress it into a zip archive. The disadvantage is that every time you update one of the files there, you need to kind of create a completely new zip archive and place it somewhere. But that's kind of how our pages works anyway. Like every time you change something, you run everything. And then when someone requests a file from the static website, you don't actually have to download the whole zip thing, because it's indexed. You can, with an offset, you can just download the relevant file. And we don't want the user to download the objects directly anyway, because we want some kind of control of who's accessing the website. So we have an intermediate kind of web server anyway. How does that sound?
it's super accurate. Like it's based on the principle that pages are being frequently deployed, and usually deploy them in the bulk. This is like the whole principle behind the pages. And like managing a lot of small files is really troublesome, even looking at the today's NFS implementation. So we can quickly read the zip central directory, know exactly where each file to serve is, and kind of serve exactly this file from this single archive. And GitLab pages become kind of self-sufficient, with Rails being even less dependent on the pages architecture, because it only manages like a single file that is put somewhere. And it's exactly as you described how it works. We read this metadata information in the single request. We know exactly where everything is. And then we kind of really selectively download the specific item from within the archive and serve that directly to the user. So like if you look at the cost, like from the perspective of the web service, you still perform exactly one request per each client request. It's exactly, it has the same cost. If you have, of course, this metadata in the memory, you still perform just the same single request as you would be serving file directly versus from within archive. It's just the same type of the request. It's instead of like downloading the whole file, you kind of read the chunked part of that file.
That makes sense. How do you know where to stop reading? So of the zip, you need to read the index to know where all the files are. How do you know where the index stops?
Index is always appended at the end of the archive. So what you actually do, there are two requests. First one, you read the location of the directory, with this they name it central directory. And the second request, you actually read all the data that are related to the central directory. So you kind of, zip is built in the way that the directory is always at the end of the archive, and you kind of read that from the backward. And this is how you know exactly how much to read.
Cool. Thanks for that. And if someone feels inclined, we can maybe add this conversation, embed them in our docs about the Pages architecture.
There is very interesting outcome that I'm really hoping that we implement at some point, like implicit GitLab review apps for basically everything. Sorry, GitLab Pages review apps. Like, since we use the same source data, we today use the CI artifacts. Like, it kind of gives us this kind of feature for free because it's already kind of supported. We don't really have to unpack anything. We just serve exactly how we serve today. So I think like there is like two interesting outcomes. Like, one, we have GitLab Pages review apps, but the second, the architecture that was built into Pages allow us to basically implement anything related to any type of the serving in the future that we may decide to do. Because it's abstracted, it's generalized, zip being very small fraction of the whole implementation. So if at some point we decide that we need to update individual files, the current architecture will allow us to add extension to support individual files overlays, for example.
Awesome. And I want to stress what you already said, like, hey, making Pages separate from the Rails app is just super beneficial. Imagine if someone had a popular GitLab Pages site and it generated tens of thousands of database queries to get the name of the cloud object or something like that for all these different things. That would be a big problem. So kind of separating this more is a really beneficial thing. I love it. And Philippe can cut out this video and add it to the Pages architecture or developer documentation.
Cool. Are there any additional questions for this item? All right. Point number 3, we moved batch 4 to our Sidekiq catch-all shards to production. We're monitoring for any writes to NFS, and given that those queues have very little traffic in general, we'll monitor them for a tiny bit longer, which leaves our list with only pages related, CI job logs related items, and then there is another one, which I need to remind myself what it actually was, which was a bit surprising. Security scans. Apparently is unknown whether it has an NFS dependency. So we are leaving that at the final batch so we can isolate any writes there. That is going to last for at least a week before we can complete it. And then number 4 is we are moving with our work on deploying to multiple clusters instead of one. And that is requiring us to make some changes to our deployment scripts. But good outcome of this is that we at least have Git HTTP traffic in Canary being served right now without any significant additional cost in the meantime. All right, those are the updates that I managed to gather. Jerry, you're up next.
I was just making a note about the MR that I had committed last week, but it turns out Jason is already working on it. So I will circle back with him, and there is an issue that distribution is using to track that.
Thanks. Thanks for working on that. What does the direction of the arrows mean in this mermaid chart? I get excited by mermaid charts. It's great. They're maintainable. People can, everyone can contribute to update them. I kind of have a feeling how to explain this, but so the Helm chart combines with the operator to deploy to Kubernetes. So this is like a smaller part of this, kind of the GitLab operator extends the Helm chart to go to Kubernetes. And the GitLab orchestrator extends Omnibus. But cloud native GitLab is not extended by anything. Maybe cloud native GitLab should be a box or something like that. I'm not totally sure.
Yeah, I could probably do a little better on this. This was put together in about 5 minutes while I figured out how the syntax worked. The way the arrows actually point out is what is consumed by what. So the omnibus is actually consumed by the orchestrator, and the orchestrator is used to provide a means of actually deploying at scale. The cloud native GitLab here is not necessarily cloud native GitLab as the product, but rather the CNG containers that we refer to. So the individual containers designed to be cloud native. That can be deployed through several means. The first is Docker Compose, which is what is often used for early development on containers. The second is the Helm chart, as we're currently using with GitLab.com, and as a primary product at this point, though is still growing. The GitLab operator currently is in a mixed phase. We're doing a proof of concept to have it directly consume the Helm chart so that it would actually streamline the development workflow for that. The Helm chart can be used to deploy into Kubernetes as of today. It technically can function in OpenShift, but with some severe caveats. And the operator itself is designed specifically to bring us on par with that ability in OpenShift and give us day 2 operations. But it also brings us the full capability to deploy and manage in Kubernetes.
Cool. Yeah, all makes total sense. And consider elaborating a bit on cloud native GitLab. Consider renaming that to cloud native GitLab CNG containers or something like that.
Sure thing. Like I said, this was a quick draft. This is on my list of actually writing up the documentation for this week. So I plan to expand on that. And we also want to actually add all the individual technologies that are included in each one so that it's clearer to answer your question from last week in regards to the combination of Chef and Terraform and Ansible and how all of these things actually come together. So they're separatized components that stack together to give us a complete solution, but we want to make it clear how exactly that functions.
Cool, thanks.
All right, Maren.
Blockers. Blockers. One item to highlight, we are not blocked fully yet, but I'm raising a concern that the charts issue slipped a milestone and we are inching towards being completely blocked. So one of the concerns I had was that there was a napkin math type comment, Jason, I would say, where you quickly investigated this, and I'm afraid that this might be a feature creep, like it might actually require quite a lot more work. Maybe it does, maybe it doesn't, but I would like to see this addressed sooner rather than later. And the issue specifically is about how specific workloads are mapped and grouped together and isolated regardless of what kind of images, container images they're using to serve the traffic from. So right now it's set to P2 and I'm planning to escalate this further in a week or so, 2 weeks.
Right. And you do have my apologies. I unfortunately needed to take a break and that was slipped. I was intending to work on that over the past couple of weeks and just wasn't possible.
Jason, that's absolutely fine, but the issue was not assigned to you. At least it's not assigned right now. So for me, as an outside observer, group distribution just triaged it and got it ready for development. Whoever is going to take it is not working on it. That's how it looks from the outside.
And I can understand that. I'm letting you know that while it's not directly assigned to me, it was on my plan of work to pick up and throw as in-dev to spec out.
Cool.
Now, to that regard, this unfortunately was one of the things that we had to push out as a result of that. We do need to finish fleshing this out. Specifically, are we talking about individual services or say like the API versus web versus HTTPS fleet and how to do that? There's actually a mix of conversations going on in this particular issue. One of them is in regards to monitoring and fleet management, and another one is in regards to traffic management when it comes to API, GET, web, and eventually pages. I say eventually because I'm really happy about the work that Camille and crew have done. And I look forward to making something out of that in the next milestone, but I can't do anything about it right now. So there is more discussion to be had and fleshed out. It probably will be turned into some form of epic.
Yeah, and that's my general concern. It's going to take a while to get it implemented. And we can roll things out to .com. Like web and API traffic are separated the way they are separated in order for us to be able to serve the request at scale that we are serving. If we mix them together just because Kubernetes right now, it's just not going to work.
Right. And the napkin math comment that you have is actually researched. It will actually function.
Okay.
The question becomes
Apologies.
how we act. Well, no, it's fair. I mean, it's a short comment. It basically needs the final fleshing and then implementation thereof. So at least when it comes to the traffic direction, that can be addressed in short order. The larger item of splitting namespace and how to manage fleets for Prometheus, etc., that becomes another one, in my opinion, that needs to be handled separately.
Maren, my question is, when do we need this?
So we needed it almost a month ago, but due to other things that moved things around, probably in the next 2 weeks, we are going to start work on the web and API migration. And that is probably the time when we are going to have this if we are to go to production.
Thank you. I'll follow up with the team.
Thanks. Are there any discussion points that we would like to go through?
As a matter of question, how do things look with the Git HTTPS traffic? I know that we have a portion of that active right now. Yep. Just wondering if you can tell us how that's holding up.
We have very low amount of traffic there right now. So we can't really draw any really big conclusions because we're only serving percentage of the traffic. But for now, the challenges we've observed are related to actual deployment. It's taking 15-20 minutes to actually deploy there. And all of that has to do with connections that are being held by the long running Git HTTPS requests. So other than that, there is not much to say or not say. It's either working or it's not working, basically. Like if you're cloning and it's working, then no one is complaining. And we are not seeing any elevated error rates or anything, any real slowdown. The only slowdown is deployment. And the reason why deployment is slowing down, it's mostly because of how omnibus deployments used to work. We now lose that slowness that allowed us to naturally have the Git deploy go within 5 minutes. Right now, the deployment would go within 10 to 15 seconds. And those connections that we would naturally kill over a period of 5 minutes, we would basically forcefully interrupt them. So right now we just have this window under which we are not rotating those pods. We're waiting for the connections to die out.
Okay, well, that's good news. that we're not having any problems with the services themselves. We just have to make sure that we don't drop anybody in the middle of connection. So
Yeah.
I'm glad that that's the problem we're running into of all
I
things.
think the biggest challenge or the biggest outcome we'll see when we move to production, and we can't move to production because of the cross AZ traffic. So that's why we're deploying to multiple clusters to save on cost.
Thank you for the insight.
All right, thanks for asking, Jason. Unless there are any other items, Jerry, you want to close it out?
Yeah. See you next week. Thank you, everyone.